Awesome. So a mortgage is taken for 200,000 over 30 years at 2.8% APR. What are the monthly payments? If you should not spend more than 30% of your monthly take-home income on mortgage payments, how much must you make yearly in take-home salary in order to afford this house? All right. And so yeah, this is a good. I think this is a relatively typical situation. Depending where you are, the house will be less or more. But you have 30 years at like I think general mortgage rates around 3, depending on credit things. So you might have more, might be less. And my general understanding is that the rule is you shouldn't spend more than 30% of your monthly take home on rent and mortgage things like that. So it's relatively accurate. But let's see. So it's a mortgage, and so a mortgage, remember, is a loan, essentially. And so we had the loan formula, which we also call the payout annuity formula, this one here. So let me write that out. So PMT equals P naught APR over N all over 1 minus 1 plus APR over N to the minus NY. All right. So this was our loan slash payout annuity formula. And because mortgage is a loan, we can use it. So if I want my monthly payments, remember when you're using this in terms of a loan, P naught is the amount that your loan is worth. The APR is the APR for the loan. And then N is the number of payments you make per year. So in this case, since we're monthly, N will be 12. And Y is the length of the loan. In the case of the payout annuity, Y was the length of the annuity before it reached 0. So they're basically the same thing. The loan is essentially a payout annuity to someone else. So let's see what happens here. So as I said, P naught is the amount in the loan. Since we're doing a mortgage, the loan is worth 200,000. So this is my P naught. My Y is the length of the mortgage, 30 years. My APR is my APR. Just remember that it needs to be a decimal. So 0.028 is my APR. And of course, you could also do that as 2.8 over 100. Is that it? Yeah, so it's going to be kind of two questions. The first part is figure out the monthly payments. The second part is figuring out how much your income needs to be to afford those monthly payments under this kind of regimen. But sorry, I was eating pumpkin seeds and I caught my throat. We plug everything in, and if we're solving for the payment, once we plug everything in, the payment will be what we get, right? Because this whole side here is what we know, and the payment side is what we don't know. So if we plug in what we don't, or we plug in what we do know, we'll get what we don't know. All right. So let's see. So 200,000, and then APR is 0.028 over 12. All right. 1 minus, and we're just plugging things in. APR is 0.028 over 12 again, because we're doing things monthly. And then it's for 30 years, and then N is 12 because we're doing things monthly. So it's minus 2, the minus 12 times 30. Right. Right. I should note, mortgage things are always very tricky. I was talking to this mortgage man once about mortgages, and I was trying to tell him some computations that I was doing to try to estimate different costs and things. He's like, "Oh, that's not how it works." And I'm like, "I don't know how it works then." So if you work for like M&T and you're a mortgage guy, it's probably more nuanced than this. I think there's a lot more that goes into it than just this, because I was trying to use a formula like this to try to like compute what my monthly cost would be, and it was not right. So I don't know how like M&T and real people do mortgages, but this is like maybe perhaps an idealized version of a mortgage. Anyway, now we plug everything like we did. So again, I'll start with the bottom here, and let me move this up so we can see what's happening on the screen. And let me move this over a little. It's like I'm framing a video. All right. So I'll start here. 0.028 divided by 12. Right. I get whatever that is, and then I add 1 plus 1. Right. And then this whole thing is to the minus 12 times 30 power. So little carety thing, parenthesis, minus 12 times 30, end parenthesis. We get that number. Oh yeah, that sounds good. Um, I was gonna say, so usually when you have this is 1.002 whatever, it's greater than one. When you raise it to a power, you should get something bigger. It's gonna be bigger than one. But we're raising it to a negative power, so it'll be less than one. So if that makes sense. Anyway, so this is this thing now. This blooper there. Oh, along with its exponent. And now I subtract it from one. So I'll do one minus, and like we talked about last time, I'll do second answer or second minus sign to get the answer from the previous line. So this whole thing here is 0.5678, which is kind of fun. And now I just need to divide the numerator by 0.5678. And again, you can do this all by rounding. You can write in different parts if you want and round, it's fine. Anyway, so 200,000, that looks good, times 0.028 divided by 12, and then divided by second answer. So 821.79. Right? So that would be your mortgage payment in this scenario. Again, where you have 30 years, 200,000 at 2.8% APR. And you could figure out how much you're paying in interest. Like if you're interested, a mortgage over this kind of period of time, you spend a lot in interest. So like, you know, if I look at how much I'm paying per month, right? I'm paying it for 30 years, 12 every month, so 12 months a year, so times 12 times 30. So overall, and the entire lifetime of this house, presumably, say I live in it for 30 years, I'm paying close to 300,000 for a $200,000 house. I mean, it's not really how it works, right? You're paying the extra $100,000 essentially for the convenience of borrowing $200,000 initially. So that extra money is the interest that the bank gets, and that's why mortgages are so good for them, because they get all this money for doing essentially nothing. They have the money, so they're just gonna give it to you. I guess there's risk, but that's besides the point. But yeah, so if you wanted to, you could find the interest portion, right? Like we did yesterday in that one problem. So it's like what, 30% just about is interest, 100,000. The total is like 300,000 that you're paying overall. So you're paying about 30% in interest, 66% or 60% or whatever is the actual principal, the actual house itself. And just like we mentioned yesterday too, when you're paying a mortgage like this, every time you pay a bit of your mortgage, the amount that you own the house goes up a little, right? Because you're buying a little bit of the house every month for 30 years. And so in the beginning, you're paying the interest mostly. Like the interest is kind of front loaded to the front of your mortgage. And as you go, you pay more and more of the actual principal because the interest gets less and less and less. So it's kind of interesting how that works. And then at any point, they could kind of compute how much of the house you own. And it won't be as much as you would expect, just naively, because the $800 isn't all your principal. It's partly interest. So it's a tricky situation.
Man,
Yeah.
when you compute everything step by step, I don't know about anybody else, but it's very helpful when you do it like you would with a regular calculator.
Oh
Because
yeah.
I don't know about everybody else, but I don't have a scientific calculator. So it is so much easier. Even if you use the one that you were using, you were still doing it step by step. And I can do that because I have that same calculator that you have.
Sure. Yeah. I'll do it like that one. Um, we'll do it with this one just again, just to see how it works. So let's see if we can see everything. I think that should be good. Like that. Perfect. All right. So again, I start at the bottom. And the only reason you can really start anywhere. You could start at the top, plug that all in, and then write it down. But I just start at the bottom because it's the most complicated looking. So 0.029, and then divided by 12. So I get something. And then I add the 1. So plus 1. Oops. So I get that. And then I need to raise it to this minus 12 times 30. So, and again, that's something you could have done beforehand too. Like you could have taken your calculator, done 12 times 30, and then just wrote that in. And then you wouldn't have to do any extra computation. So there are other things you could do. It's really, there's no right or wrong. Anyway, to the minus, so it'd be, again, parentheses, and then the minus sign at the bottom under the number code things. So minus, and then 12 times 30. All right, let's see what we get. So we get that. And then I'm doing 1 minus that. So again, even on this calculator, it has the answer. But if you didn't have that, what you would do is you would do something like this. You'd write 200,000.028 over 12 all over. And then what I would do is I would do 1 minus, and then I would do point, and you can round to whatever, 4, 3, 2, 1. The more places, the better for your answer. And then you would just do this in your calculator. So you do 1 minus 0.4321 to get that, and then even that you can keep going. 200,000 0.028 over 12, and then over I could put 0.5679. All right. And yeah, so if you don't want to, you don't have to use any special functions in the calculator. Even if you have one of those like I think they're like accounting calculators. They just have simple addition, multiplication, division, and addition, obviously. Even if you just have one of those, assuming it is exponentiation, you can get by. And then you just kind of continue. So I'll do 200,000 times 0.028, and then divided by 12. And then, so that's 466.66, whatever. And I'll divide it by 0.5679. Right? And you should get something about the same. This one you'll note is slightly different. So it's 821.74. It's 5 cents off. This one is more accurate because I didn't round it all, but it doesn't, if this was a test or a homework or something, I wouldn't take off points because you're 5 cents off, especially if you showed work. Like if you showed this work, I would know, oh, they rounded, so they have slightly different answer.
I do have a question though. If we were to do it this way on my open math,
it would not work. Yeah.
No.
Yeah. You just have to be much more careful with your rounding, or use again. So it's second, and then down here above it, it might be hard to see, but there's ANS, and that just means use whatever the previous number that the calculator popped out. Right. You would just use that. And it'd be more accurate. You could also use online calculators. Wolfram Alpha, again, is what I like to use sometimes. Wolfram Alpha. And it's this website, and it will give you a lot of stuff. You can basically just type it all in. It might take a little bit of time to type it all in, but it'll give you an exact answer as well without having to fumble with a calculator. Yeah. Cool. So, and that was the harder part of the problem. The easier part is the second part. So maybe this is part A, perhaps. And then part B, remember it said, how much do you need to make to afford this house if you want no more than 30% of your take-home income to be this payment, right? So what we'll do is, so this is B maybe. So I want my take-home income, 30% of it, to be at most this number. This is my monthly mortgage. So what I'll do is I'll do take-home income, and say monthly, right? And I want 30% of it to be at most that number. So I'll do times 0.30 or 0.3. And I want it to be equal to 82174. Right, and that's the most it can be. I'm taking that whole 30% and saying it's all going to my mortgage. That's the situation. And so now to solve for my take-home monthly income, I just divide both sides by 0.30. So my take-home monthly take-home income can be at most, or I guess at least, 82174 over 0.3. So I already have it up, luckily. So divided by 0.3. So to afford this house under this standard where only a third of your income can go towards your mortgage, you would have to make monthly equals, it would have to be, you have to make monthly 2,700, say 39 bucks, give or take. I mean, it's not like a really hard and fast rule. You could pay a little more. If you paid 35 or 40, it probably is not going to kill you. But it's just a guideline. So you'd have to make about that much every month to afford this house. Right? And that might be kind of lax too, because I think things like utilities are included in that 30%. Anyway, all right. Questions? All right, so let's try one more of these. As I said, these are just the last two from Tuesday. So this one's a credit card. Suppose you have a credit card with an APR of 22% and a balance of 10 grand. So how much do you have to pay every month? All right, good luck. Good luck, Jolene. I'm sorry about your internet. I know mine was being weird too. Maybe it's Zoom. Suppose you have a credit card with 20%. Yeah. So you want to see how much you must pay every month to pay a card off in 1 year. Right. So the credit card is a loan essentially. So we're going to use the loan payment formula. So I'll rewrite it.
My Zoom this morning was being really, really jacked up too.
It's weird. They must be having some problems or something. Because I've never had an issue. Whenever it just kind of always loads instantly. I mean, 4 minutes isn't really anything to write home about, but still, it's odd. There we go. Oops, down there. There. So that's the one we just used. And again, remember what the variables mean. So it might sound funny, like how much must you pay every month to pay it off in 1 year? But remember that the Y here is not, I think this formula is a little funny, and just like the savings plan formula, because the Y isn't like, if you plug in Y equals 2, it's not how much you have left to pay off after 2 years. It kind of shifts things. So it's like basically the Y is the term of the loan. So like in the house one we just did, we put Y equals 30 because it was a 30-year loan. So it's not like a situation where you can plug in a year and get the amount on the loan. It's more of a situation like you're plugging in a year to denote how long the loan overall is. So you have to be kind of careful, especially because like with the compound interest formula we did, you can plug in higher and higher Y's and it gives you the amount in the account. And so it's not like that at all. The Y is you're fixing the Y and saying, oh, it's going to take this many years, 30 years to pay off the loan, or in this case, 1 year to pay off the loan. So I guess in this problem, you probably would have guessed to plug in 1 for Y anyway, but just kind of be careful. Anyway, so as I said, that means Y is 1. And everything else is everything else, right? So the APR is 0.22 or 22 over 100. So the APR is huge for a credit card. I don't think it's generally that high, but it's still decently high. I think it's usually in the teens. And then P naught is my $10,000 loan or my credit card debt. And that's it. Oh, and it's monthly. You want to do things monthly. So N is 12.
My mom refuses to get a credit card if it's any higher than like 15
Yeah.
or something
Yes.
like that.
Mm-hmm. Yeah, some of them are really bad. And then you have other loans too, like predatory loans, like, I don't know, they're kind of sketchy. But yeah, I
Well,
think,
I know like my uncle has horrible credit, and
yeah.
like when he took out a loan, he took out like a high risk loan.
Yeah.
It had a ridiculous amount
Yeah.
of
E- e-
um
Even this 22% is gonna be pretty bad. And you can see even after a year, you'll see that I don't know what the exact numbers end up like in this problem, but I think even after a year, you'll have a substantial amount of interest on your 10,000. So it's not great if you have bad credit. But as I said, we just plug everything in. So let's see. So PMT is what we're looking for. We're looking for what our monthly payment will be. So let's see. And yeah, we'll do it and then I'll talk. So 10,000. And then my APR we said is 0.22. Monthly again, so 12. Most things are monthly, I think. And then in the bottom, 1 minus 1 plus 0.22 over 12 to the minus 12 times 1. Right. So just plop everything in. Let's see what happens. We'll try to do it all nice and accurately with our scientific calculator. Let's see, that might work. All right. So 0.22 divided by 12. It's that. So remember what this is too. This is our monthly interest. So every month you get, so 0.22 divided by 12. So every month it's just shy of 2% interest, right? And then plus 1, right? So that's this. And then 12 times 1 is 12. So I don't need to do anything there. So it's just 2 to the minus 12 power. So carry thing. And then I still like to put parentheses. I don't know how sometimes these calculators work. So to the minus 12 gets that. And then 1 minus that number. So again, I'm going to do 1 minus, and then I'll do second, and then negative sign to get that. And then bam. So it's 0.195 stuff. And that's the whole bottom now. And so now I'll plug the top in. So 10,000, yep, times 0.22. And then, oh, actually, I'll do this, sorry. I'll do parentheses 0.22 divided by 12. And then I'll do divided by second answer, because the previous thing that I just got was my denominator. So it should work. And so every month I have to pay $935.94. All right. So it's like a decent chunk of change every month. And remember, so there's 12 months in a year. I'm paying almost $1,000 a month. My whole balance was only 10,000. So if I multiply this times 12, overall I'm paying 11,000, or sorry, yeah, $11,231. So overall, so $11,231.32 on my $10,000 loan, right? So it, again, it's like the mortgage. You're paying for convenience to use this money that you theoretically don't have, right? That, credit card, you can put $10,000 on a credit card. You didn't theoretically have the cash, but you might have it in the future. So that's what you're hoping on. And they're charging you interest for that convenience. And it's just like the mortgage. The mortgage is lower though, because it's over an extended period of time, and it's a little less risky than like credit card debt. So the bank isn't putting their money at risk as much as the bank is here. And again, you could figure out what portion you paid in interest versus principal, and that isn't too bad here, right? So if I take my total cost that I'm paying and subtract 10,000, my principal, I get that number, right? So if I divide it by then what I'm paying overall, 11,231.32, and times 100. So my interest here is, I don't know, like 11% of what I'm paying. Right? So it's, every time you pay $100 on this card, or to pay your card off, 11% of that, or $10, is just going straight to the interest. It's like money you didn't necessarily spend on anything for yourself. It's a convenience fee. Right? So you can do this with any sort of loan that you take, mortgage, credit card. If you take like other, I don't know, that's the other kinds of loans, small business loans, things like that. They all will sort of work this way. Again, they might be more intricate than this. This is kind of a generalized loan formula. Certain loans might have more intricate details. Maybe the interest changes over the years. It could be anything. So, you could just be careful with the details, but they all generally work like this. And you can always do this where you see how much you're actually paying for what. Yeah. All right. So questions about those two things? All right. So, Lord, I don't need you anymore. I need you and you. All right. So as I said, so it's 4:30. The rest of the class, I want to talk about this. And it says that this is going to be in lieu of a homework assignment for this unit or this section of material. And so basically the premise is that you're acting as a financial planner for this couple, Jim and Pam. And I give you this kind of extended setup here, and I have to add this in, so don't worry about that. But I give you this extended setup, and there's some detail that you can get into, and there's no right or wrong answer for this kind of situation. It's got a little bit of a creativity aspect. You can kind of play around with the numbers and see what works best, what you think would work best. But basically, the premise is the one person earns $32,500 a year after taxes. So you don't have to worry about taxes for this. Just assume this is their yearly take home. So for instance, if you wanted to figure out Jim's monthly take home, you would take his yearly take home, so 32,500, and you divide by 12. All right, so every month he makes about $2,700. If you wanted his bi-weekly pay, you divide that in two. or bi-monthly pay. And so every 2 weeks, he gets about $1,300, right? And you can do the same for Pam. And so, as I said, I put some detail on it. So each year they can expect a 2% raise, right? So for instance, in the first year, if Jim makes 32,500 and he gets a 2% raise, then we're using that percentage stuff we worked on, right? So I'll multiply it times 1.02. And so that second year, he will make about 33,150, right? And Pam, something's comparable. So you can take that into consideration. They have 9,500 in savings, and a savings account generating 1.2% interest compounded monthly. Right. So as I said, there's quite a bit of details. Their monthly expenses are as follows, and I hope I didn't forget anything. I tried to think of everything that a person pays for. It's obviously it's a fake situation, so don't worry about it. But they pay $850 in rent. They're currently renting. $70 in electricity, $125 in internet and TV, $105 for their cell phones, $35 for garbage, $1,000 every 6 months for propane. They're living off the grid. $450 for groceries, $100 for their dog, and $300 a month on miscellaneous. Maybe they need to buy, I don't know, a new mailbox or something. So that the miscellaneous is everything else. You'll note that there's no like sewer or water bill because again, so in this situation, they live like in the country and they have a propane, they have a well, and they have a septic. Assume for the sake of the problem that their house doesn't need, or they don't need any weird things. Right? Like maybe they'll assume that their well is not going to break. And the next 10 to 15, and this is the problem here. This is what you have to focus on. So
I mean, if they have a septic, it could overflow.
don't say that. It's not going to happen. And so, yeah, in the next 10 to 15 years, they want to do two things. And this is your job, is to figure out how they can do it with all their fixed incomes. It's not really that fixed, but you understand. They want to buy a house. They want to have a kid. The house will, and again, so they have a price range for their house. For the sake of the problem, assume it will cost $150,000, and the yearly taxes once they buy it will be $4,500. Assume again maybe they got a credit check. I don't know. Assume they can get a 30-year mortgage with an APR of 3%. All right. Also, they will need to put down 20% as a down payment, and there will be yearly maintenance of around $1,000. All right. So, oh, and I'll add this when I post it online. But there's also 4% closing costs, and so basically how that works out is the house costs 150, right? So I'll give you a hand to do some of this for you. So the house will cost 150. And so you have to put down 20% in this situation, or they want to put down, I don't know. That's their goal. So you want to put down 20%, so times 0.2. So 20% of 150 is 30,000. So they need to have $30,000 on hand in cash in order to buy the house. And then there's 4% closing. So the closing costs are things like lawyer fees, inspections. What else is there? There's other things. If they're getting a mortgage, so there's a lot of costs associated to getting a mortgage. You have like signing costs and stuff. It all adds up, and it's all under this umbrella of closing costs. Anyway, it's 150,000, and then so it's 4% of that. The sale price. So 0.04. So the closing costs themselves are 6,000. So they needed 30,000 for the down payment, another 6 for the closing costs, and those are all things you have to have this on hand in cash too. Yeah, so 36,000 they need for the house, not counting the taxes that they'll need for the following year. All right, so that's for the house. And then they also want to have a child at some point. And the order, they don't care about the order. They can have a child before they buy a house or after. They don't. It's your decision as their financial planner. Anyway, the child will cost approximately $12,000 per year in a sorted cost. And that's what it is on average, which is kind of crazy. And it goes up every year. Your child grows older, they cost you more money. I read it peaked around 14 or 13,000 when they're like a teenager. So they're so expensive. But yeah, so that's the setup. And so your job, as I said, is to using what they get every month in salary, you want to figure out how they can do A and B, right? So that's it. And so what I want from you is, and I don't really, I'll leave it up to you exactly how you format it, but I kind of want a year by year breakdown of what they're doing. I want you to tell me are they starting a savings account? Like they already have this savings plan with 9,500 in it, but are they going to add to that savings account monthly at some rate? Like we talked about the savings plan formula, this one. And so what you can do if you want to do that, you can use this and try to and play around with the variables and say, well, how many years will it take for me to save up $36,000 with, you know, with the confines of their salary? How much will I have to put into my account every month? That kind of thing. Again, in order to save up enough to buy the house. And then once they've done that, once they bought the house, you can use the loan formula to figure out what your mortgage will be. And keep in mind that like you don't really need like this rent they're only paying before they buy the house. So after they buy the house, the rent will go away and you'll be paying a mortgage instead. And I think it'll work out similar, it'll be almost the same, just about. It'll be more once you take the taxes into consideration. But yeah, so you can use the loan formula to figure out what the mortgage will be. You can use a savings plan formula to figure out how much they need to put in their account every month to save up 36,000 for the down payment and the closing costs. And you also have to figure out how they'll afford the kid as well. And then there's also, they get these raises every year, 2% raise every year. So if you can't make the numbers work in the first few years, you can say, oh, well, I'm going to have them wait 4 years or whatever, until their salary's a little higher. And then I'm going to have them like buy a house, and then I'll have them wait a few more years and then have the kid, or you know what I mean? So you have about 10 to 15 years. I want you to have it all fit into, all right? And as I said, I want a year by year breakdown. So every year I want you to tell me kind of a gist of what they're doing. Detail, tell me what their salaries are. So year by year. So at the least, you should be telling me what their salaries are. You should be telling me what their savings account balance is. Saving account balances. So after their savings accounts and after they pay all their bills and put money in their savings accounts, do they have leftover money? Things like that. And then when will they buy their house? They buy / have a kid. Right? So you just have to go up through once they have a kid. Once you have them have a kid and pay for that do like a couple of years, you'll be good. So maybe end when kid is 3. Give or take. Again, I think, as I mentioned, like I'm not gonna be crazy in the grading. I just want to see you try to make sense of all this data, and I want to see you have to use the formulas we've worked with. You have to use the savings plan formula, you have to use the loan formula, and you have to use just the compound interest formula, right? So for the savings account, that's the compound interest. You have to use that because their savings account gets, what was it, 1.2% interest monthly. So, every year, if say they're putting in money in their account, maybe you use the savings plan formula, have them save for 5 years. And then after that, maybe they don't have any more money to put in. So you just let it sit there for another 3 years or something. During those 3 years when it's sitting, you have to figure out how much interest it's getting as well, even though they're not putting money into it. Yeah, so use at least those 3 formulas that we talked about: the savings plan, the loan, and then the compound interest formula. And you can, if you're into Excel, you can make a nice Excel sheet. If you want to do everything by hand, feel free to write everything out by hand. If you're doing it by hand, you can show me the work that you do in like each of the formulas. You can write while you're doing it. If you want to use Word or something, feel free to use Word, put tables in it. But I just want to see year by year what's happening, and I want to see how they're paying for their house and things like that. All right, any questions?
Yeah.
It's kind of open-ended. Yeah.
Okay, so you said end when the child is 3. What if you have a child and then buy a house? Or just after 3 years after you do both?
Yeah, do it 3 years after you do both. and 3 years. That's a good note after both. Right. And it's what I just kind of wanted to see, make sure you're allowing them to, like, you're budgeting them to pay for all of them for at least a few years. Like the kid costs 12,000 a year, so I want to see that somewhere they have money that you've allocated for them. I'm like dying, so they can afford everything. Right. I think it's possible. I I haven't run the numbers. I'm pretty sure it's possible. It might not be very good for them. They might have like no extra income, but I think it should work. They're like collectively they're making what right now at the beginning they're making 72,000, which is a decent. That's a lot of money, um, especially since their house won't be. It's not 150,000 is like an average, very a low average, especially nationally, not locally, but yeah, this is kind of like I feel like this is kind of a realistic situation for a couple in this area with good jobs. So I don't know. Any other questions?
Remind me when your office hours are again.
They are after class. I haven't had anyone take me up on it. I have notes somewhere. I think they're online too. My note. Oh wait, just a second. They are 7 to 8 on Tuesday, Thursdays.
Okay.
Or whenever you want. I taught Gary and I chat a lot at 4 on like Wednesdays and Mondays. So anytime really, just shoot me an email if some other time works better. Anytime after 3, that's not class time, will work generally. Sundays work too, most of the time. I don't know. I've been busy Sundays, but yeah, just shoot me an email too if you want to meet anytime. But don't stress too much about it. I just want to see that you're kind of playing with all in the information and just do your best to try to incorporate everything you can. You'll get credit assuming I see that you put some effort into it. Really, because there's no right or wrong answer. The wrong answer would be like you saying they can't afford it. Something where you didn't show any effort. But if you put effort in and try to work with it, you'll get credit. So it should be fun, and it should be hopefully instructional or hopeful to you at some point. Because most people want A or most people do A or B at some point in their life. So trying to understand how you could finance those things might be cool. All right. Any questions?
Did you want us to take pictures of it to send to you
Oh,
the
yeah.
answer?
Yeah, if you just get it to me, however, if you're doing it by hand, which is totally fine, just be neat. Yeah, just take pictures of it and email it to me or something. Um, but yeah, if you're doing it by hand, definitely show all your work because, as I said, I will need to see those three that you're using at least those 3 formulas in some capacity. So show me how you're using those and state why. Like I kind of envision it being easier done as like a Word document, like a written assignment almost, with incorporating. You can use tables and stuff like that. That's how I would probably do it as a Word document, and then make some tables and kind of have everything organized and just kind of show me what their financial history is going to look like for the next 10 to 15 years, give or take. And I don't know exactly how long it will take. It should be doable. I think I added up all their monthly costs, and their monthly costs were like $2,000 a month. So that's like what 24,000 a year. And even if you round, if you take a higher number than that, like you just like even if you pretend Jim's salary doesn't exist, like just get rid of Jim's salary, you still have you still have $40,000 salary left over. So they should be pretty good. Now the kid will kind of screw you up a little because 12,000 is a big hit. So part of her salary will be gone right away. Um, but you should be fine. It should be fine. It should be doable. It might have to wait a few years. And don't, uh, I don't know how much they need to save. If they save $1,000 every month, then they'll earn or save what 12,000 a year, and then as I said, they need 36,000 to buy the house. So that's 3 years of saving $1,000 a month. That's kind of doable, So if you just kind of plan it out like that, and you can figure out the details at the end, like how much they would actually save with the savings plan formula if they saved 1,000 a month. because you know that they save at least 36, which should be enough for the house and the closing costs. I don't know about taxes. You'll have to figure that out, how that kind of feeds into it, but it should be fine. Yeah, I think you should be able to do both in 10 years, but at least 15 at the most, but I think 10 should be comfortable. Okay.
Hey Matt,
Yeah,
is the 450 for groceries and 100 for their dog food? Is that monthly? I'm assuming.
yeah.
Okay.
Yeah.
Oh yeah, their monthly expense. Okay.
Oh, yeah.
Sorry.
No, it's okay. Yeah, those are monthly. Yeah. And if you want to adjust things, feel free to adjust things. Be like, maybe $450 is enough for your characters for food. So you can add more to that. Just don't cut
Okay.
things. Don't cut things. If you cut too many things, it's too easy. So feel free to add things, but don't take anything out. All right.
Okay.
Yeah. Any other questions? Hopefully it's a relatively fun activity. I don't mean for it to be stressful. I hope it to be a little more fun than the homework is. So
No, I think it's gonna be fun, but I think it's gonna be stressful when you first start it because there's a lot of numbers.
there are a lot. There's a lot to take, especially things like the 2% raise every year. So what I would do for that is like I would just figure out what their salaries will be each year, for like 5 or 10 years or something, because that's easy to do. You just multiply it times 1.02. And you can do that, just make a table of those. And then from there, you can work on what their yearly or monthly salaries will be for each of those years. And just kind of break it down and give yourself an idea of what's happening. But don't like kill yourself. Don't go too stressed over it. It's, it should be fun. Any other questions? All right, so it'll be a little short class just because I just wanted to talk about this today and finish up those notes from the other day. Yeah, if you have any questions, let me know. But give it a go. Try to figure it out. Just play around with it, and let me know. If you need help, feel free to shoot me an email. We can schedule some office hours outside my normal ones, which are 7 to 8. But yeah, Tuesday, Thursdays, any other day usually. Just let me know. All right, I'll see you.
Matt, how's your new job going?
All right. It's fine. It's at Bose.